Okay, thanks, Torn. Okay, so for today, what I'll be talking about is stable diffusion, like lesson 9. Okay. Um, there's a lot of information in the lesson. There are 3 videos, and let me just make a sort of like quick overview and let you know what resources how you should access these resources, because it may take a while to look them up. So you have from the course.fast.ai website, you could directly find Jeremy Howard's video. That's the video that you should watch first. There's no long form text for this part, unlike the ones that you see in part 1. That's the first thing. The second thing is that there are 2 other lessons, 9A and 9B. 9A goes into more of the details of stable diffusion, but more from sort of like more or less fixed programming kind of point of view. So it's like you have a lot of chunks of code and then they basically run through it. But there's a nice part in 9A where they look at they sort of like have a visualization of how this sampling is going on, like where's the word diffusion coming from. So that comes in around 30 minutes into the video. So that's something that might be interesting to look into. Uh,
Yeah, I'll be the first to admit that I watched the main video, did not do 9A and 9B. I don't know if others are in the same boat.
I didn't
And
even know there was a 9A and 9B.
yeah,
yeah,
yeah, there's a couple links
Aren't those
below the
extra
main video.
credit?
I'm not even sure if I wanted that extra credit, but yeah. And then
I guess the question for you, Andrew, is that's interesting. You said they talk about kind of where diffusion comes from, but I mean, is it worth my while? Should I invest the 2 extra hours, I guess, going through
uh,
those
I think you
those
have
videos?
to for 9A, I think you could jump directly to sort of like the concept. If you want the conceptual part, jump 30 minutes in. But if you
Hmm.
want sort of like have a casual view of the code, then you go through everything in 9A, because Jeremy doesn't go through code in
Right.
in, in their
Mhm.
video,
Yep.
right?
It's more of a high level kind of
Yeah, I mean,
how is this working?
Yeah.
I kind of felt like the whole purpose of this video was to kind of put the roadmap together for this whole section, right? So these are all these elements we're going to dive deeper into, right? He just wanted to put
Eventually.
this is the whole framework of it's kind of a neat concept, right? We'll just use stable diffusion as our project to hang our hat on here, but we're going to go into detail about all these different things like the embeddings and transformers at some point to do the text embeddings and CNNs and how those work in detail. And I guess even further down, looking at the topics like back propagation and all
Yeah.
that. So
Exactly. So eventually you're gonna go through it a bit deeper as you go along, but it depends on your preferences. So if you want a casual view of what the code kind of feels like, then 9A is also a good starting point. But if you want sort of like high level conceptual, Jeremy does a good job of that. And you could actually jump in 40 minutes in if you really want to. So you could skip the first part. You could also use the 1.75 or 1.5 mode if you if you're into that kind of stuff. It works. I think it's still audible at that stage. Okay.
Yeah, I'm one of those people. I also didn't watch the other two.
Yeah. And the 9B, how should I put it? You could watch it, but I think it might be more confusing in the sense that there is notation that you might not be so used to. So for example, for the normal distribution, where if you're from a stats background, you're expecting 2 parameters, right? But in that video, you might see sort of like 3 things inside a normal, like n and then 3 things. So you might feel weirded about that, but you shouldn't, because it's really just a conditional normal distribution. So there's an in for every for every input that you condition on, there's a different normal distribution that is attached to it. So that's I think the part that might not be very that might take a bit getting used to. But aside from that, I'm not sure if it I'm not sorry, but I'm not sure if it really helps. So you might do times 1.75 for this one. So let me put it this way. There.
Good to know.
And then in lesson 9, as Ron says, it's really big picture. So what I didn't like about the lesson is that there's no sort of like, we're not on the same page when you come in. So you do have to pay attention to the words that are being used. And if there's a word that you know, chances are it might not be the word that you think it is. So let me put it that way. So let me mention those things. So for example, when they say the word model, it's actually those boxes. Okay, the magic function that Jeremy refers to. And then when you think about sampling, the samples are really these images. Okay, you're drawing images, so to speak. And then sorry?
In more ways than one, right?
Yeah. And in more ways than one, exactly. And then you have the phrase diffusion models. What are they really about? Okay, so these are really machine learning systems that are trained to denoise random Gaussian noise step by step. So actually, if they started with this definition, you would naturally ask a lot of questions right away, and it becomes conducive for discussion. So for example, why is it that we want to denoise random Gaussian noise in the first place? And I think that's what Jeremy also sort of like kind of motivates a lot in terms of the handwriting example, I think 40 minutes into his video. Okay. The other thing is that this word latent, this is really a lower dimensional representation of an image. Okay. Again, in stats, you also have a different notion of latent, but again, it's sort of like a hidden part of the image, so to speak. So you could think of it that way. And then when they use the word inference, it's really using a pre-existing model to generate images. Okay. And then when they use the word training, it's really fine-tuning using new data. And training is not done in lesson 9. Only you're asked to play around with things. So you're really doing inference there. So those are the words that you might encounter in lesson 9. Okay. So I'm dividing this notebook into 2 parts. The other part, one part is to use stable diffusion right away as is. So you're a casual user and you just want to produce images just for the heck of it. And then you have another person who is, I want to see what's inside. Okay. So there are you're serving 2 audiences here. So the first audience I'm going to talk about now, which is how do you use stable diffusion directly? So there in the course, in course.fast.ai, you'll see a repo called diffusion NBS, diffusion dash NBS. And there are 2 notebooks there. Stable diffusion deep dive. So it's called stable diffusion deep dive and a stable diffusion only as the name of the notebook. Stable diffusion.ipynb is the notebook that Jeremy uses. The deep dive is 9A. Okay, there. So that's so I think it helps to have a separate notebook for your work, because you might find that you couldn't just randomly start anywhere and then expect things to run. So you have to do a bit of work. So you have to update also the things that are in the notebook. So that's what I'm contributing here. So if you
was that pretty straightforward? You were getting like error messages or something when you were trying to run these? Okay.
Yes, I get error messages. So you have to figure out some things here and there. Okay. So I use Paperspace for this for this part. I use the start from scratch option, not the paper space fast AI one. I just use start from scratch. And now it's DigitalOcean, FYI. And you have to change the transformers version to 4.28.0. And I wanted to load the minimal libraries so that you don't get, I don't know, this is more of like a personal thing.
I
And
didn't
then,
find that necessary. I mean, I did the exact same thing. I mean, you start from
oh,
scratch,
really?
paper space, and I just
Huh.
did the pip.
You
This
did
is
the pip and then everything. I guess it depends on which notebook you use. So if you use Jeremy's notebook, I think it works.
yeah. I used Jeremy's notebook, not the deep one.
If you use the deep dive one, then you have to do the
Well,
adjustment.
the deep dive when they put in a particular version number, and if you just didn't do that, would it work better? I don't know.
I guess so. So I followed the error message, like, okay, I just upgrade.
Okay.
Okay. And look for the most how should I put it? Not the most recent one. The one the one that passes the
Yeah.
the minimum. And you need an access token for Hugging Face. Okay, if you don't have that, you will not be able to generate images. Now in Hugging Face, let me just mention that you'll find that you have to create an account. And when you create an account, in settings, go to settings, and then you'll have this page that you see here, and you look for access tokens. And then you have to create a token that will allow you to access those to be able to use Hugging Face. And here there's a part here where once it generates an access token, you will not be able to find it again and after copying it to the clipboard. So if you want a new one, you just have to invalidate and refresh every time. Okay, so that would be the idea for this one. Okay, and also there's a sort of like an error, not really an error message, but a warning that the stable diffusion pipeline is no longer using this authentication token, but you still need access to Hugging Face through that token. Okay, so that's essentially from the stable diffusion deep dive. There's also this is the one thing that I forgot to mention. The reason why I use deep dive is that Jeremy's original notebook doesn't load completely in GitHub, but it does load completely if you open it in a viewer.
I noticed that too. At first, I
Yeah.
thought I was missing a bunch of stuff. Like, oh, he doesn't have all this stuff he's talking about. It's not in this notebook.
Yeah, exactly.
I cloned the repo and looked and like, oh, it is in there. Okay, never mind.
Yeah, so I didn't clone the repo. I was like, okay, oh, it's not complete. Okay, then I ignore it. That's why I went to deep dive. Yeah. So this is really the command for it to install the stuff. And then these are the minimal libraries that you need to get things to work as is. And essentially you're using a pre-trained model here. Okay. Okay. And the use auth token here is gone. Okay. You'll still get some warnings. To be honest, I really don't know what these mean anymore. So once you run this, and I think I'll do that. So let me do that and do that. After a while, you'll see something coming up here, which will ask you for the access token from Hugging Face. So when you run that, sorry. Yeah. And then you'll see a login part here. You have to change this token here and then just log in and then things will be okay. Okay. Hopefully it's done. Yeah, I think it's okay. I'm hoping it's okay. There. And then here's what I just did. I did a fruit fly sipping a white Russian in the style of a stained glass painting. So let me put it that way. And let's see what happens.
Pretty good.
Yeah. It has the default of 50 time steps. Okay. It takes a while actually. It takes a while.
This is I'm assuming the free paper space, right? So not
The
the
free one.
primo GPUs.
So this is the specification that you're seeing here: 30 gigs of RAM, 16 gig GPU, and cores, I think.
That's the same one I used.
Yeah, so it's a bit
Yeah. Took about a minute and a half, 2 minutes.
yeah. So you also have to be careful here if you want to use the one that has four by four grids in the other notebooks, that would take a while.
Yeah, I did it. It took, I think it was 40 minutes. I don't know. I was like, wait, why is this taking so long? I didn't realize it was doing 4 times 4, so 16.
Yeah, so
Like 2 minutes, so 32 minutes. That's about what it took. Yeah.
oh my God, I was waiting. Oh, this is taking a bit too long. So okay, so I stopped going through it.
By the way, a little tip,
Yeah.
while this is going, that Jeremy showed is instead of using this notebook interface that Paperspace gives you by default, you can use, don't do it now, but that you can hit that Jupyter Lab button down there, and you can use Jupyter Lab instead, which get a nicer, better to use. This interface is kind of weird the way I have this. It's like hard to figure out how to add cells and stuff. That's one thing. I also use the I have a paid version, which gives you a nice feature where you can launch a remote kernel. Here, you can access the kernel remotely from your desktop. So I just use Visual Studio Code on my desktop and do everything that way.
I see.
You connect to the kernel on Paperspace.
I see. Okay, that one I didn't do.
But you can do that without. What's that button above it do? Is that the same? Is that what I was talking about?
Access
Yeah,
remote.
that's you can do it. I guess you don't need to be paid.
It's pretty much clear that I only clicked on these two.
All right, let's see your picture.
So this is the
Oh,
picture
neat.
for a fruit fly sipping a white Russian in the style of a stained glass painting. Okay, FYI. If you really want to see an actual,
Pretty abstract there.
if you want to actually see a fruit fly, remove this part, this other part. If you want, you could, instead of a white Russian, a Mai Tai. You could also try that. There. So that's essentially what that's what it is. And here is a version where you have those 4 things, but I didn't go through it anymore. So if you want to go through that, it uses fast core. So you have to install fast core because it has this concat part. Okay. So you have to track all of these things down. But I found this error, sort of like an error here. So there was a potential for a NSFW kind of content, FYI. So have fun with this part. I'll leave it to the imagination what it produced. I think you could turn it off if I'm not mistaken. So there. And then you'll have other prompts that it's also possible to modify the pipe that you run. Instead of just putting the prompt, you could have the sort of like pass along some options if you want. Okay. So this is one option, one thing that you could do for the watercolor painting of an otter. I think this is in deep dive, but I wasn't really able to replicate the one that they actually have, because when they did this watercolor painting of an otter, they were not using the stable diffusion pipeline anymore. They sort of like tore it apart and looked inside the hood, and then they had some other settings inside. I'm not very sure how to sort of like create the appropriate command here so that you'll be able to produce the output that they show in that notebook. FYI there.
Andrew, do you know like why it is you need to have the login for the Hugging Space?
I think it's because the stable diffusion pipeline is from from the Hugging Face. So diffusers is from Hugging Face. At least that's my understanding.
Well, it's just a library though, right?
Yeah.
Or
But
I guess when you download the model, it wants to know who's doing it. Is that what's going on?
that I'm not sure, but this is sort of like the thing that they mentioned, that you have to have that token. So I guess this library is not, it's publicly available, but to actually use the infrastructure, you need to get into Hugging Face
But the
somehow.
only thing you're using from them is downloading the model, right?
I think so.
So the second time you do it, you shouldn't have to log in because it should already have the model
In
down.
principle, yes, that's true. So
Oh,
when
there's
you
that
do the
safety
second-
checker. Interesting.
yeah, unless you do the restart, if you restarted the kernel, then you have to do the login again, if I'm not mistaken. Yeah,
Yeah, well, you restart the computer,
yeah,
you probably will, because everything will be
Yeah.
lost.
that's
There's some way
right.
to cache it on Paperspace, but I haven't learned how to do that yet.
I see. There. So that's the how to use it for images alone. Okay. It would be nice to do the re-engineering kind of stuff, like if they tear everything apart and everything was as is, we just look under the hood and what are the settings that I have to pass through pipe so that I'll be able to produce the painting that they actually have in the deep dive notebook. I wasn't able to do it with just the ones here on the top. Okay. There. Now we're now gonna go to the user who wants to look inside the hood. Okay. So if you want to customize Stable Diffusion, then you have to understand that there are actually 3 parts, and not all of them are moving at the same time. Okay. One thing that might be, this took me a while to understand if you only watch the videos alone and you want to figure it out for yourself without going through other people's stuff. And there's just so many write-ups of this material, and it could get confusing after a while. But essentially there are 3 separate components. So you have the VAE, okay, the variational autoencoder, and then you have clip, which is the one where you have the text text embeddings now, where the text is converted into embeddings, and then you have the UNet. So essentially it looks on sort of like high level, it looks like this. Okay. High level, this is what it looks like. Okay. Now the variational autoencoder, what it really does is its only task is to compress images and then decompress them. That's its only task. Okay. And as I mentioned here, okay, for the VAE, there's the compression part and the decompression part, the encoder and the decoder. And the encoder input is some image, and then the output of the encoder is a latent representation, which is a lower dimensional representation of the image. So typically, the image that you input is high resolution, and then the encoder output would be a low resolution one, so to speak. And then the decoder takes as an input some latent representation of an image. It doesn't necessarily have to be the encoder output. Okay? It doesn't necessarily have to be the encoder output. As long as you have some latent representation, it could be used as an input. Okay, of course, with the right sizes and stuff, depending on what the decoder is. And then it outputs an image. Okay. Okay. So those are the 2 components of the VAE. Okay. But
Hey, real quick, I'm just thinking about the video, the main video, and I think Jeremy spent a lot of time on this. He had the diagram of where he starts with the large image, right? And then he's taking strides, right, to make the image smaller.
Yeah.
And then he does something before the decoder to change the number of to get the number of channels to a smaller number. I wasn't quite following that part. I certainly followed the stride component, right?
Yes.
Lowering the height and width of the image. But does anyone recall what was going on there with the channels?
That was also my question. So when there was a sort of like an extra step, right?
Yes.
And then it's not very clear what happened there. And then when you see the decoder, you don't see it being undone, right? Yeah. So I don't know. So that's a bit of a mystery here for me. Yeah.
Okay.
Yeah.
Part of that might be because it is a VAE. So in the latent image is not just a compressed image, it's actually compressed images and standard deviations of the compressed image, so to speak, as we will learn when we get to VAEs. But it's a Bayesian type thing where you get both the some means and standard deviations at that level. So that
So
might be part of the complication of that part.
yeah, so that one I'm not very sure, but that was something that you should pay attention to. That something it was there, and then suddenly when you see the decoding, you don't see it being undone, right? Okay, there. Thanks for reminding me of that. Yeah, but the way Jeremy frames it is that if you take both of them together, the target is really to make sure that you have some sort of fidelity between the encoder input and the decoder output. Okay, so the idea is to spit back the original image as much as possible. Okay, but that's his framing. In the stable diffusion version, strictly speaking, these two could be separate from each other. Okay, and actually, you might not even need the encoding step if you already have the latents. Okay, another thing, but you do need the decoding part. Okay, the decoding part is the last step of this UNet process. Okay, okay, because you have the decoding part is sort of like upscaling the image back to its original size. Okay, so that's where it really comes from. Okay, so as you can see, this VAE, you could also flesh it out even further, that you have a VAE encoder showing up here, and then in the UNet part, there's a VAE decoder here somewhere. Okay, something to that effect. Okay, and then and that's where the VAE sort of like shows up. Okay, the other component of stable diffusion is clip. Okay, this clip, the thing is that what it does is that it gets some input, which is the text prompt. Okay, that's the one that you pass, and the text prompt has to be converted into something that that could be understood by the computer somehow. So there's this embedding that that it outputs, and sort of like the fascinating thing for me here is that the part where these Jeremy talks about the alt text that is being used along with the images that you collect from the internet, right? And it can be used to train this clip part. So that led me to thinking about, did accessibility sort of have a causal effect on the, you know, having the push for accessibility made it more likely for these kinds of technologies to, you know, to prosper somehow, right? So might be interesting to think about that. But for clip, the idea is that you want a consonance of the text and the images which are related to the text. So in Jeremy's discussion, there is this matrix where the diagonal entries have to be maximized, or it has to be very, 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 very near one, and then the off diagonal entries has to be very, very near zero. And the idea is that you're trying to, the loss function here is sort of like the so-called contrastive loss. I didn't go through the details of this, but based on the video, this is the sum of the main diagonal entries minus the sum of the off diagonal entries. You might feel, I think I felt awkward here as well, because you want to maximize that thing, right, rather than minimize it. So you just have to take a minus. So you can think of it that way. So there. So that's the part about clip. Okay, there's nothing very detailed about it. It's basically taken as is. Okay, it's taken as is. Okay. Now the next thing is the UNet. Okay, so let me go back. So for the UNet, it takes inputs two things, as you've seen in the diagram earlier, the either pure noise or the latent representation plus actual noise. Okay, so those are the inputs for the UNet, okay, and the clip embeddings, okay. So in terms of this figure here, actually, once the VAE encoder produces the latent, okay, once it produces the latent, okay, the UNet adds noise. So at least you have to add noise to it. So plus noise before it goes into the UNet, okay? Or you could choose to actually even get rid of the entire VAE encoder part and just plug in noise directly, okay? So that's at least that's how I understood it. And the point and what UNet does is to predict noise itself, okay, to predict noise itself. And the target is to compute this thing called a noise residual, and it's the input minus the predicted noise. So the idea is to train the UNet in such a way that it's very good at finding what the noise is in your image and then removing it afterwards, okay? So the output of this UNet is a denoised latent. So this one produces a denoised or a latent that where the noise was removed, and then afterwards it goes into the VAE decoder, and then once image you hopefully want. Okay, so essentially that's what happens. So UNet will produce the denoise latent, and then you pass it through a VAE decoder, and then the VAE what the output of the VAE decoder is a high resolution image of what you want. Okay, so that's in a nutshell, this is what it looks like. Now you might wonder where the text is coming in. Okay, you might wonder where the text is actually coming in. So because so far I've been talking about noises and images, okay, but the word text here doesn't show up. It turns out that this is where the guidance is coming from. Okay, so guidance is coming in this stage. So the guidance is sorry, like the text is used as a guide to refine the images that are being produced by UNet, okay? Because when you do UNet, what it does, okay? What it does is that you have this magic box, and then you have this input, UNet, and this output. It actually goes back in, okay? So, sorry. All right. Output denoise latent and puts it back in. Okay. And it does this recursively. Okay. So this is a refinement of the image. Okay. And then there's a part where the text guides the refinement process. So you can think of the text as like an additional regressor. So if you think of this as a regression kind of model, the text is like an additional variable that you put into the regression. Okay. And there's a part of the code where the guidance comes in, and you basically take a weighted average of the noise and the one that has the guidance, the image that is produced with guidance. But this weighted average, the weights, doesn't have to be between 0 and 1. That's the thing that you see, that you will notice from the way it's implemented. Okay, there. So that's sort of like the how should I put it? The high level, or the pieces of this whole puzzle. Hopefully that sheds light on things. You might wonder, why is it called UNet? The U is coming from if you go to the actual paper, there's a picture in the second page that looks like a U. I think that's where it comes from. Okay, in case you're wondering why it's called UNet. Or if you wish, the U could stand for upscaling, if you want, but yeah. Yeah, so at the end of the day, the stable diffusion is really a text represent, there's a text representation that generates and then there's an embedding that is being generated, and then there's an image representation that is being refined, and both of them are sort of like being used in the process through the guidance system, the guidance scale, okay, to produce the image that you want, okay, and the image that you want comes from a VAE decoder, and this VAE decoder takes the input from whatever the unit is producing. Okay, so roughly this is how I understood this whole thing. Hopefully it's roughly correct. If it's not correct, you should let me there. Now you could look into the hood. So this is where they break things apart. And the code here, I separated the part where they sort of like set up the three components, the VAE, the clip, and the unit. Okay. And if you notice, they all come from pre-trained sources. Okay, so that means that there's room for you to jiggle things around if you want to. Okay, and then it downloads a lot of stuff. Okay, so let me just run this. And another thing to pay attention to is that the schedule, there's a part here that is called the scheduler. This is the part that is not really discussed so much in Jeremy's video, but is in 9A, okay, and in 9B. Okay. Jeremy argues that this is the part that should be not really ignored, but I would put quote unquote in ignored based on how he describes it.
Well, I mean, I would think, I mean, he talks a little bit about this. This is this time business, right? He was somewhat like, you know, it's called a scheduler because there's this differential equation background to the people that did this originally. And so they called this time, but time is essentially just the noise or beta. So the scheduler here is scheduling how the noise is added on, I guess, right?
Yeah. So there's a noise here, a part here where you add noise, right?
Right.
So the way you do the refinement is that you don't just add a constant, the noise is not constant, okay? So it's constant for one, but as you continue refining, okay, the noise you add, it becomes lesser and lesser, okay? Essentially, that's the idea, and it follows a schedule, okay? So as you refine further and further, the less noise you add, okay? At least that's what you would see in the picture where you see a downward sloping on the y-axis, on the vertical axis, you see the amount of noise, and on the horizontal axis, you see the time step, okay? So that's where it's coming from, okay? He doesn't talk much about this noise scheduler because the way unit works, and
He will next week, though, I think.
Yeah.
I mean, next week he's going more into the rest of that notebook.
Oh, really?
He's talk about schedulers and things. So
Great. So, but just to preview it, it turns out that this part here, where you're using some guidance to refine your images, okay, that guidance scale could be thought of as a learning rate. And that's probably the most insightful part of the video, okay? That you could turn this whole business about stable diffusion don't express it in terms of differential equations language, but instead convert it into deep learning language in terms of optimization, in terms of SGD. Okay. So in the diffusion, in the deep dive, you will see that the guidance scales are sort of like it's a hyperparameter that you have to give it to the computer. Okay? You have to supply it. Okay? Or you have to give a range for the guidance scale. So in a sense, it's no different from trying to find a good enough guidance scale so that you would get what you want. So in that sense, you transform the differential equations, sort of like terminology, into the usual part one language. And that's probably the most insightful part of the video. Okay, there. So this part is sort of like understated, okay, in Jeremy's video, but in 9A and 9B, you might see this. Okay. And then you could get the code from 9A, okay, from the deep dive. They have this colorful dancer, not Geo photo, okay, and they have two versions of the code. One is where the input here is just pure noise. Okay, the input here is pure noise. The other is the input is based on a pre-existing image, okay, that you supply. So that's another version. And that pre-existing image doesn't have to how should I put it? It doesn't have to come from something that is pre-trained or some training data set. You could just supply that image right away and then pass it through the VAE encoder, turn it into a latent, and then go through this UNet stuff. Okay, you could do it that way. So those are the two versions that you will see in the code for deep dive. And here is a version where so I had to modify the code a bit, but one version is where you have the pure noise as a starting image, and there's a version where you see the macaw, the one that looks like a parrot of sorts, okay, as the starting image. And you just comment or uncomment the parts that are relevant. That's it. Another thing to point out here in the looking under the hood is that there's a part here where you have the text input and the unconditional input. This part here is probably interesting as well. The part where you have support from the text and the one that doesn't have support from the text. Okay, that's where it shows up. Okay, and then you produce two embeddings, and then you have this scheduler, and then it goes through this whole thing. Probably the most important part here is this one. Okay, so you have the prediction under if you didn't have the text, and then you have the prediction of the noise if you did have the text. And you would see that there's this weighted, you could re-express this as a weighted average, but this is also very nice because you could see right away that if guidance scale is equal to 1, then you're using solely the text, the one that uses the text completely. And then if you adjust this to something between 0 and 1, then you have something in the middle. But you could also make guidance scale larger than 1. Nothing restricts you from doing that. And in fact, in the code for deep dive and in Jeremy's code as well, I think the guidance scale is, I think, default 7.5. Okay, so that means that there's even more fidelity towards the text prompt as much as possible. Okay, so
I wonder
those,
why you have to do that. What does
Sorry.
it look like? What does it look like when you maximum guidance versus mid-scale guidance or something?
yeah, so I think that feeds into his discussion about optimization, right? Like, is there sort of like a sweet spot for this? And what is the criteria? What would be the criteria to get to enable you to talk about what a sweet spot would mean? Okay.
Yeah.
One thing that is probably not very clear to me myself is the presence of this for the macaw image, okay, as the starting point. They have this 0.18215. I'm not sure where this is coming from, but they have to undo that somewhere here. So I have to create one that is, this is uncomment if macaw, comment otherwise. So if you're using the macaw image, you don't have to do the adjustment. But if you use the macaw image, then you have to do this 0.18215. I'm not sure where it comes from. It's probably because of the sizing of the image, but I'm not very sure. Right? But essentially, you would be able to get this. If you run that, you will be able to get this this colorful dancer. This is from Pure Noise, I think. This is from Pure Noise, and it produced this Nat Geo dancer. Not very perfect, but good enough. No, there's a part here that looks a bit missing, but quite not, still not bad. Okay, there. I think broadly this is it for lesson 9, I think. There's not much to discuss aside from those bits and pieces that Jeremy leaves behind. Like, could we reframe this as a part 1 thing rather than a differential equations thing? And then the focus here for lesson 9 again is inference only. Okay. If you want to do some more training, there are options available in the sense that in Jeremy's notebook, you would see different workflows for stable diffusion. So some I've already discussed. One is about guidance. The other is about passing a pre-existing image into stable diffusion. The other is to give negative prompts. So let me just show you that negative prompt. The negative prompt is the one where they have this Labrador, okay, where they want to remove the blue parts from this image, or this de-emphasize the blue parts, and you would see that the blue doesn't show up anymore. Okay, but the curious thing about this is that the dog used to have sort of like the eyes of the dog are clearer now in this image, and suddenly the dog has a mole here. So I'm not sure what's going on there. I would think that it would just be directly the blue parts gone. But yeah, FYI. And then there's a part here where they have this you can add new tokens called textual inversion, or you could use Dream Booth, where you already use an existing token, but use a rare existing token. Okay, so that's also some to train further along those lines. So that's those are the other things you could play around with in terms of Jeremy's notebook. Okay, but roughly speaking, this is what it is all about. Okay, for the moment. Yeah, hopefully it was helpful to you. I think I should stop there.
Yeah, thanks.
Yeah.
Yeah, I liked your diagramming, Andrew. That was actually helpful for me in understanding how the pieces kind of work together.
I agree.
Glad that's the case. It's a bit at first you would think that all of them are needed somehow, but actually there are only a few parts that are really truly needed. Okay. And it gives the impression that should we train all of them at the same time? I don't know, right? So that also seems to be an open question. Should we train all of them at the same time using the same images, or should it be a diverse set of images for each of those components? I don't know. Okay, there. So yeah. But if you want to dig into the mathematics, 9B could be a start, but I don't know if it would help really. But yeah, there. Okay. Anything else you want to talk about, or that it seems okay?
Yeah, nice job.
Yeah.
Yeah, great presentation.
I
Thanks,
really
Andrew.
do look, yeah, thanks, Andrew. I do look forward to digging into all these little pieces and parts, so it should be fun. I hope.
Yeah, hopefully. But it's harder to work with part two because there's no long form of the material. So it can get a bit tricky. You take more time. Yeah, 8 hours is not enough, I think, to go through it.
Yeah. And Jeremy's kind of all over the place with the stuff too, right? So it's kind of hard to pick out the parts that you should be focusing on.
Yeah,
Yeah, I noticed a significant change in the presentations from part 1 to video 9.
yeah. I think it might be good to do a long form of this, sort of like this part as a pet project. But again, it depends on the time that you have, because it really, it's a rabbit hole. Let me put it that way.
Yeah, maybe there'll be another book on this, but who knows if Jeremy will actually do it. He has like another for-profit enterprise going on right now. I don't know if you guys saw this, Fast HTML.
Oh yeah,
Is
I
his
saw that on the YouTube.
Yeah. Um I'm guessing he's just kind of wealthy from other you know companies he's started and sold, and he was kind of doing fast AI just for because he was passionate about it, and now he's kind of started another company looking to make some
Yeah.
more dough.
It seems like how should I put it? The workflow nowadays, like you have a free resource and then you reel them in, and then it's a common
Yeah.
thing. It's our it's this decade's how should it's the feature of this decade.
Yeah, the guy's kind of branded himself, right? So you
Yeah.
like his stuff, and check out Fast HTML.
Yeah, but admittedly, he really explains things very, very intuitively. I must say. But I think if you try to reconstruct what he's trying to say, it might take a while for you to really, get to a better understanding of things. Otherwise, you'll be parroting the same things that he says. That I
Mhm.
that's one thing to notice there.
All right.
Good
Well,
point.
yeah, thanks again, Andrew.
Thanks
We'll
for
check
listening.
in on John and see y'all next week.
Yeah, take care,
Sounds
everyone.
good. Thanks so much again, Andrew.
We
See you
put
next week.